I'm going to go ahead and get started with it. And whenever you feel like taking a sneak peek, take a sneak peek. All right. Here's how I would start with this, guys. So question one, this is from the 2012 AP exam. And it wants, you can use a calculator, so I would use a calculator. And it says, let R be the region in the first quadrant bounded by the x-axis in the graph y equals ln x, and y equals 5 minus x, as shown in the figure above. I hope you can tell which graph is which. This linear line is a linear line, 5 minus x. And if you don't know, that's fine. I mean, I would hope that we know, right? And that's y equals ln x. And they want to know this area. So letter A says find the area R. So to find the area of R, I need to figure out that x value first. I need to figure out what that value is. So here we go. The first thing I do is I'm going to go ln x equals 5 minus x. You do not have to show anything else besides that. And then just show what that x value is. That x value is, and I don't know because I haven't typed it into my calculator. So here's my calculator. So let's see if you guys can see my calculator here. That guy. So here's my calculator, and I'm just going to go to y1 and type ln x. And I'm going to go to y2 and type 5 minus x. And if you want this graph to look like this one, then I would change the window to look like this. So window negative 0.25 for the x min, x max, let's see, 1, 2, 3, 4, 5. Go to like to 5.5 maybe. X scale by 1, that's fine. Negative 0.25 to, I don't know, what's that, like 2 or maybe, like 2. So there it is, and I'm going to push graph. Yeah, that looks like that one. Find that intersection right there. How do I find the intersection? You guys help me out? Can you guys help me out with that? How do I tell the calculator to find it? Guys, what do I do? How do I tell the calculator to find my intersection?
Second trace.
Number 5? Perfect. And then because I only have 2 curves, you can just push enter, enter, enter. And then when it says guess, there's only one intersection. So just push enter. And there it is. 3.6934414. 3.6934414. I think I can remember that. 3.69. I was wrong. 3.69344414. And I like to go down the alphabet. What letter do you think I'm going to use? A, because I said down the alphabet. Okay. So there it is. I use letter A, and I'm good. Now I can go ahead and find my area of R. So I'm going to go, my area of R is going to be integral. And where do I start? At 1. And I'm going to go all the way to A. And that is just the ln curve plus integral from A all the way to, this is A down there, 1, 2, 3, 1, 2, 3, 4, 5. All the way to 5 of the 5 minus x curve. And I know this is a triangle, and maybe you're just like, do 1/2 base times height. Like, yeah, I can, but I don't want to because of that A. If A would have been a nice integer, I would have just done 1/2 base times height, but I don't want to do 5 minus A times half times whatever ln of A is. I don't want to do that. Or, 5 minus A, whatever that is. So I'm just going to go ahead and just type it in the calculator, guys. So here's my calculator. I'm going to go math, number 9. Oh, I got to go to the home screen first. Math, number 9. From 1 to, oh, I just realized I don't even have A saved in my calculator yet. Dummy. Not you guys, me. If I push X, it should still be there. There it is, 3.69344. I push the stove button, alpha A. So now it's saved as that A value. And now I can finally do what I want to do, which is this integral here, mass 9 from 1 to a of ln x, and then close this dude, put an x on it. If you want to do it two separate ways, like calculate the other one and then add the other one plus the other, you can. I'm just going to do it in one line here. Plus mass 9 from a to 5. And I just realized I'm not even using my y1 and y2. I'm just going to go alpha trace y2. No, I don't have to do that, guys. I could just type in 5 minus x dx. And hopefully everyone got this number. 2.9858. 2.9858. 2.9858. And there it is. That's it for letter A. Letter B. Letter B says region R is the base of a solid. Like, oh, okay, that's the base of a solid. So this is where the solid is touching the ground, I guess, paperweight or something. For this solid, each cross-section perpendicular to the x-axis is a square. So it's a weird shape. It's coming out of the paper. The biggest square is right here where A is at, because that's the biggest side. Right, but do not evaluate an expression involving one or more integrals that gives the volume of the solid. They're making it really easy for me, guys. I already found the area on the top. All I got to know is how to find the area of one cross section. Remember, you have a square coming out of the paper. How do I find area of a square? It's just what's squared. Yeah, that's it. That's all it is. Side squared. Side squared, guys. So the integral is going to look exactly the same. 1 to a. But instead of ln of x, what am I going to type in there? Perfect. Perfecto. Ln of x squared. That's it. Where did the ln of x squared come from? From the side squared. Now, we're not done. We need another integral, right? Plus integral from a all the way to 5 of, again, same thing, 5 minus x, close it, put a square on it. And it's funny that they don't want us to calculate it. I don't know why. I think the calculator can do it. It doesn't look like a super hard one. But there it is. We're done. We explained what a was back in the top. But if you want to show it again down here, if you want to be like super careful, you can. But I think the reader should be smart enough to know the grader, like, oh, there's your A. And I'm pretty sure they would tell them in the notes, like, hey, guys, don't penalize them. They're using the A from above because here it is. It says capital A and it says capital A. So we're good. How do we feel so far, guys? Yeah, so far so good. So far we're good.
Sorry, can you explain why you squared them?
Yes, because my cross section, the area of a square, so this length right here, for this cross section in blue, this in blue is this part right here in blue. And that length is ln of x for just to the left of this of A, right? So how do I find area of that squared? Area of that squared is just ln of x squared. And then as soon as I pass this button in blue, this point in blue, so this one in black here, that in black is, here's my cross section, is this here in black. And that is 5 minus x. So how do I find the area of that part? Is just 5 minus x squared. Yeah, I just squared the side because area of a square is side times side. I squared the side. Did I answer your question, miss?
Yes, thank you.
All right. Now here we go. This is a hard one. And there's actually so many answers. I didn't get a chance to look at the rubric. I had just finished it, and then I was about to start on question 2, and then I got distracted with a whole bunch of paperwork. Letter C. The horizontal line y equals k divides R into 2 regions of equal area. Underline the word equal area. Write, but do not solve an equation involving one or more integrals whose solution gives the value of k. Guys, there are so many answers to this. Be creative. Be as creative as you want, as the juices, let the juices flow through you and write all that good math stuff in here. Does that even make sense? It doesn't, right? Okay. It is, but I can choose how I want to. They just want an equation that would allow me to solve for k. but it doesn't tell me. Do you know what I mean? Like I can write, I can think of two of them right now, right off the bat. So here we go. Everyone focus on this. So come up here and focus on this guy. So they're telling me y equals k divides region R into two equal regions of equal area. So here's y equals k. I'm not sure if it's right there, guys. I'm just drawing something. It's probably more down because it looks like I have more area in the bottom than the top. So let me write it a little lower. Something like that. It doesn't matter. Somewhere in there, right? Region 1, region 2. I want those areas to be equal. Well, I already know that the total area is 2.958. You know what? I don't even want to include the 2.958. Not right now. Here's what I'm thinking. If I start integrating with respect to x, there is too many variables. I need to know this. I need to stop at a, and then I need to know this. There's too many variables. There's too many things going on. There's too many moving parts. So let's remove all those moving parts so we can have less of them. So instead of integrating with respect to x, I need to integrate with respect to, there's only one other option. If it's not x, I have to integrate with respect to what letter? Y. And look, if I integrate with respect to y, going right to left, I don't have to worry about splitting up into two integrals. There's only one. This is the only curve going right to left. That's on top. There's the only curve going right to left. That's on bottom. I just need one. Okay. If I were to do it with respect to x, I would have a lot of different components, and I would have two integrals. So I'm going right to left with respect to y, dy's, because that way I only have one integral. I'm integrating with respect to y. So think of the cross section. Well, it's not a cross section because it's not volume, but I'm slicing it like this. Boom, boom. So what's always on top? That linear line. What's always on bottom? The ln x. And there's only one integral. So what I'm trying to say is this. The integral, and I'm going to call this, I already used letter A, so I'm going to call that B. So the integral from 0 to B of the linear line minus the logarithmic of dy is equal to 2.9858. Just if I were to integrate with respect to y, see 0 to find r, yeah. Which I could have done that for letter A if I wanted to. Does that make sense? Yes. Okay, so here we go, guys. Here's one option. And don't worry, we could have actually done that for letter A. I didn't think about it until just right now. But yeah, here we go. One solution. Well, I'm going to integrate from 0 all the way to k. I don't know what k is. And I need to turn these in terms of x equals something with respect to y. So this was, what was that? Y equals 5 minus x. So this is x equals 5 minus y. And then this one with y equals ln of x. So this one is x equals e to the y. Side note, y equals ln of x, x equals e to the y. So hopefully we all know that, guys. Please know basic algebra. All right, here we go. Integral from 0 to k. What is always on top? The linear line. 5 minus y dy. There's so many answers. Equals, that better equal the integral from k. Oh, I don't know what that top value is. Okay, I'm going to find it. I wrote it as b already. So here's how you find it. It's very simple. You already found it earlier, actually. E to the y equals 5 minus y. And then I'm going to say, well, y is. And then I'm going to put an arrow, and I'm going to put it into b. So I'm going to go back to my calculator. I already have it, guys. I already have it. Can you guys see my calculator? It's not on though. Let me turn it on. I might need to put new batteries in here. Guys, you guys didn't get the joke. It's okay. Look, that intersection, the y value is what I want. Second, calculate numero cinco, number 5. Enter, enter, enter. And it's at 1.306558 1.306558 I think I can remember that. 1.306558 1.306558 Yay, I was able to remember it. There it is. And I stored it to be. Chavez, I don't know how to get the y value on the home screen. Yeah, you do. Push alpha and then y. Alpha and then look for y. Y is right there where the number 1 is. And then push enter. And there it is. So store, STO, alpha B. I got everything I need. This is just one answer. This is not the only one. From K to B, and it's going to be the same thing. 5 minus Y. Oh, why did I put dy over here? Man, how come you guys didn't tell me? 5 minus Y, e to the Y. How come you guys didn't tell me there, guys? Equals 5 minus Y minus e to the Y. Yeah, sorry, I'll go slower. There it is. Now it's correct. Upper minus lower. That's one answer. This is one of them. There's many. If you don't like that, you could have done this. You could have said 0 to K, 5 minus Y minus e to the Y, dy equals half of 2.9858. Could have done that. You could have also done the other one, K to B, 5 minus Y minus EY equals half of that. And I'm sure there's other more clever ways to write this out. Should we go look at the rubric? Yes, ask, please. Oh, because I'm integrating with respect to Y, not with respect to X. So, yeah. I'm adding up all these areas. Look, I'm moving right to left. What is the Y value on the X axis? 0. And then I keep going up, up, up until I reach this line that it's supposed to be cutting my region 1 and 2 into equal pieces. What is that Y value at that line? K. K all the way to B. If I want to set region 1 equal to region 2. If I want to do that. Or remember, because they're the same, that means that it splits it right down the middle, the 2.958. The 2.958 right down the middle. So you could also say half of that. I'm actually curious to see the rubric, to see what the rubric wrote. I want to see if the rubric did number 1 or number 2, or maybe something else, maybe something funky. You guys ready? What year was that? 2012. Let's look at it, guys. So math OneDrive, Math Life, Calculus, College Board, Free Response, AB, Scoring Guidelines. Yeah, no, my digital life is very organized, but not my real life, but my digital life is organized. 2012. Here is the Scoring Guidelines. Look at what they did on letter A. Wow, letter A was 3 points. They're lame. They used the letter B. Oh, no, they used the same letter we used. They went down the alphabet. They said AB here. ln of x equals 5 minus x equals 3.69344. Therefore, the graph ln x and y equals 5 intersect that. You do not have to give all that. I would not even bother giving that information. I would just give this and then just go right into this. 2.986 or 2.985. 986 is rounded, 985 is truncated. There it is, 3 points. They give you 1 for the integrand, 1 for the limits, and 1 for the answer. Wow, that's cool. They also do the other one. I guess they prefer method 1. They also did it with respect to y, 5 minus y minus e to the y. And they got the same answer. All right, let's go down. Letter B. Exactly, yeah. Letter B is going to look exactly for everyone, guys. There's no other way to write letter B. Don't worry, miss. We're almost done. We're almost done. Okay, look at the route they went. They went to half the 2.986. It's okay. I don't mind. I think number one is better. I think mine is better. But letter C, this is fine. That's a fine answer. And there it is. You don't have to solve for anything. This is just an equation. Remember, guys, it's just an equation. We can use a computer. We can use our calculators to figure out what that y is or that k value is if we really wanted to. But no, that's it. Just an equation. Leave it alone. Done. How do we feel? Yeah, see, it takes practice. But now that do you kind of see what's going on? All right, we got another one, guys. We got one more. Do you guys want another head start? Okay, you got a calculator. Take a 5-minute head start, guys. I'm going to go ahead and get started, guys. If you are close to getting your answer, keep going. It says, let f and g be the functions defined by, and they tell you f, and I type that into y1, and g, and I type that into y2. Let R and S be the two regions enclosed by the graph f and g as shown in the figure to the right. Find the sum of the areas in region R and S. So the first thing I do is type y1 and y2, type those in. The next thing I do, I need to find that intersection right there. Well, okay, I'll talk there. I just thought of something that's really smart, but let's not go that route yet. So I need to find that intersection right there between R and S. So I'm gonna make my window look like that one. So let's see, I see that's 0.2, I see that's 0.24 way up there. So I'm gonna click window, negative 0.25 all the way to 2.25 would be a good 2.25. X scale by 1, negative 0.25, maybe go all the way to a 4.25 or 4.5. 4.5 graph. And it should look more or less similar to what you have there. So there's my y1. And here's my y2. Beautiful graphs, very beautiful. And then I'm going to tell the calculator to give me that intersection right there. Second, calculate number 5. I have two curves, first curve, second curve. There's several intersections, but it's already there in the middle for me. Enter. So there it is. That's the value I want. 1.0328319. So I'm going to store it into A. X. Transfer it to alpha A. All right, there it is. I'm ready to go. So here's what I'm going to type. I'm going to first say that I'm going to equal them to each other. So I'm going to write 1 plus x plus e to the x squared minus 2x equals x to the 4th minus 6.5x squared plus 6x plus 2. Because they give you f and g, you can just say f of x equals g of x. But I like to make it look mathy. And saying f of x equals g of x doesn't make it look mathy enough for me. And then from there, I'm just going to type that number, which I already forgot. 1.032831888. So 1.0328, 1.0328. Hook me up with the other digits. 3188. One more. Store that into A. The more digits you can write, the better, in my opinion, when it comes to integrals and all this. All right, here we go. Integral from 0 all the way to that x value, which is A, but I have it stored, to A. And then what curve is on top? The f or the g? I think that's the g. G of x minus f of x dx plus integral from A all the way to 2, and now it's the f of x that's on top, f of x minus g of x. Now, this was the first year that I was at the reading. I wish I would have graded this question. Don't quote me because I don't remember, guys. It's been a long time, 2015. That's a long time ago. I think there was some very smart students that did this. They just looked at it and they were like, they want the area. I don't care about direction. Integral 0 to 2, absolute value, f of x minus g of x. And I believe that gave the right answer. Because all it's doing is subtracting that, and whatever that is, turning it positive. subtracting this point, going backwards here, but whatever that is, turning that into a positive and adding them all up. I would not have thought of that. I think they gave them credit. I think. Don't quote me. This is the safe route. Let's see what that is. I don't remember which one I put on what. I think this is Y1, this is Y2. So make sure to let me know if I put it backwards. All right, so here we go. Math number 9, and we'll test our system, see if it would have been correct. 0 to A of Y2 minus Y1, so alpha trace Y2. Ouch, look at this, dummy me, not you. Alpha trace Y2 minus Y1 with respect to X. Sorry guys that I can't go faster. I'm literally have to click button by button here because my fingers are too fat, so I can't really. Anyways, math 9, and then I'm gonna go from A to 2, alpha A to 2, and I'm gonna go Y1 minus Y2. Alpha trace Y1 minus alpha trace Y2. And then I'm gonna push X. And let me know if I made a mistake somewhere. Did you guys get 2.004 as an answer? Awesome. Gives you the same thing? Perfect. 2.004. Check it out, guys. So Godinez just verified for me that the absolute value does give you the right answer. Yeah, if you would have seen it right off the bat and been like, I don't want to worry about that intersection. Math 9, 0 to 2. And then I'm just going to click on math. Number, the very first one says ABS, absolute. And it doesn't even matter the order. What did you type? Y1 minus Y2? I'm going to type Y2 minus Y1 just to be different. Alpha trace Y2 minus alpha trace Y1, just to be different from Godinez. And then put X here. And check it out. Oh, man. Okay. It doesn't like it, but it's going to give it to you. Notice that the number is a little different after the third digit or after the fourth digit, or fifth, actually. After the fifth digit, it's okay because it's working really, really hard. That's why it's 3 decimals after the decimal accuracy. 3 digits after the decimal. I can't even talk right. But there it is. We got the same answer, 2.004. So that's smart. That was very smart by some of those kids that noticed that. I would not have gone that route. I think it was full credit if they did that route. This is the better route. Finding the intersection, what's on top, what's on bottom, because you're telling the author or the reader that you know what's on top and you know what's on bottom, that you know Raymond sums. That's really what you're telling them. Okay, here we go. Letter B. Region S is the base of a solid whose cross sections perpendicular to the x-axis are squared. So now we just have to focus on region S, guys. It's coming out of the paper. So we already know that's A, and this is 2. So we just go, the volume is equal to the integral from A to 2. And then which one's on top? Was it G of X? No, F of X. So parenthesis, F of X minus G of X. And this is the length of one cross section. And remember, area of a squared is what? S squared. So you gotta square that. Done. Type it in the calculator, just like that. So here we go. Oh man. Math 9, alpha A to 2. That's why you gotta be careful, miss. And then F of X, I already forgot which one did I have. That was Y1. So parenthesis, open parenthesis, alpha trace Y1 minus alpha trace Y2. Close it, put a square on it, and then put a dx right there. And there it is, 1.283. Chavez, why is the volume smaller than the area? Well, this is only one region, and this is cubic units, not square units. There are no units here, so we're good. But if you want to write cubic units, that's fine. All right, finally, letter C. I haven't done any of these questions, so we'll figure out. Hopefully, we're correct on all of them. I think we are. We're confident. Let h be the vertical distance between the graph of f and g in region S. Okay, we're still looking at region S. So this is a vertical distance. I'm going to call that h. That's what they call it, right? Let h be the vertical distance between the graph of f and g in region S. Okay. Find the rate at which h changes with respect to x when x is 1.8. Well, it sounds to me like it's just take the derivative of h. What is h of x? Upper minus lower because it's just a y value. This curve up there was which one? The g of x? That was f of x? Oh, man. F of x minus g of x. So all it sounds to me is like I'm just taking a derivative, dh dx equals df dx minus dg dx. So we're just taking a derivative, guys. I don't think it's anything extreme. I think this would be full credit because it's in the calculator section. If you want to write it out, let's write it out. H of x equals, what was f of x? 1 plus x, 1 plus x plus e to the x squared minus 2x, e to the x squared minus 2x, minus, parenthesis, that's a long polynomial, x to the fourth, hook me up, so that way I don't have to. Plus 2. I'm not going to bother distributing the negative, and then I'm just going to say h prime of 1.8. So I take my calculator. Here's my calculator, and that's just derivative, and I already have derivative in here. I have it in y1 and y2, so I'm going to go math, and I want to say it's number 8. And I'm going to put x, and then I'm going to write y1. Wait, was df y1? It was, right? So alpha trace, let me go to the home screen. Sorry. What was I doing? Oh, yeah. Alpha trace y1 minus alpha trace y2. And remember, this is all with respect to x. And then in the x, I put 1.8. Enter. So there it is. The rate of change with respect to x is negative 3.811. Negative 3.811. I have a habit of truncating. If you want to round it, they should have taken 812 as well. I have a habit of just whatever the first 3 digits are, that's it. So my habit is truncate. You don't have to have my habit. If you want to round all the time, round all the time. That's what Delta Math does. Delta Math always rounds.